The 2005 National Electrical Code (NEC) does not mandate the use of hard-phase raceways for branch circuits that are protected by arc fault circuit interrupters (AFCIs). There seems to be a misunderstanding regarding this requirement. It is crucial to refer directly to the code language itself to avoid misinterpretations. The NEC is updated regularly, and each edition may introduce changes or clarifications to existing rules. When working with electrical installations, it is important to consult the most current adopted version of the NEC in your jurisdiction. Although hard-faced raceways are not required from the panel to the first point of an AFCI circuit, there is a significant requirement concerning the neutral conductor in AFCI circuits. The 2005 NEC stipulates that the neutral conductor for an AFCI-protected circuit must return to the same panel board from which the branch circuit originates. This requirement is directly related to the proper functioning of the AFCI device. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. They work by monitoring the current flow in both the hot and neutral conductors of a circuit. An arc fault is characterized by an unintentional electrical discharge between two or more conductors. This discharge creates a high impedance path, which limits the current flow. However, the reduced current flow may not be high enough to trip a standard circuit breaker. An AFCI detects arc faults by analyzing the current waveform. Arc faults produce unique signatures in the current waveform, such as high-frequency noise and irregular current patterns. When an AFCI detects an arc fault, it quickly trips the circuit, interrupting the flow of electricity and preventing a fire. The requirement that the neutral conductor return to the same panel board is essential for the AFCI to accurately detect arc faults. If the neutral conductor is shared with other circuits or connected to a different panel board, the AFCI may not be able to properly monitor the current flow and may fail to detect an arc fault. The shared neutral conductor can introduce noise and interference into the circuit, which can mask the arc fault signature. In addition, a shared neutral conductor can create a parallel path for current flow, which can reduce the sensitivity of the AFCI. By ensuring that the neutral conductor returns to the same power board, the NEC minimizes the risk of these problems and ensures that the AFCI can effectively protect the circuit from arc faults. It is important to understand the specific requirements for AFCI installation outlined in the 2005 NEC. Firstly, AFCIs are typically required in bedroom circuits. This requirement is intended to protect occupants from electrical fires while they are sleeping. Bedrooms are considered high-risk areas because they often contain flammable materials such as bedding, clothing, and furniture. Secondly, AFCIs may also be required in other areas of the home, such as living rooms, dining rooms, and hallways. The specific requirements vary depending on the jurisdiction and the edition of the NEC that is adopted. Thirdly, the NEC provides detailed instructions on how to install AFCIs correctly. These instructions cover topics such as wiring, grounding, and testing. It is essential to follow these instructions carefully to ensure that the AFCI functions properly and provides adequate protection. Here are some additional considerations for AFCI circuit installations. Firstly, use appropriately sized conductors. The conductors used in an AFCI circuit must be sized correctly to handle the expected load. Undersized conductors can overheat and create a fire hazard. Refer to NEC Table 310.15 to determine the appropriate conductor size for a given load. Secondly, ensure proper grounding. Proper grounding is essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Make sure that the grounding system is properly installed and maintained. Thirdly, avoid shared neutrals. As mentioned earlier, shared neutrals can interfere with the operation of AFCIs. Avoid sharing neutral conductors between AFCI circuits and other circuits. Each AFCI circuit should have its own dedicated neutral conductor that returns to the same panel board. Fourthly, test AFCIs regularly. AFCIs should be tested regularly to ensure that they are functioning properly. The NEC requires that AFCIs be tested at least once a month. To test an AFCI, simply press the test button on the device. The AFCI should trip and interrupt the flow of electricity. If the AFCI does not trip, it may be defective and should be replaced. Fifthly, understand AFCI compatibility. AFCIs are not compatible with all types of electrical equipment. Some electrical equipment, such as variable speed motors and electronic ballasts, can generate noise and interference that can cause AFCIs to trip unnecessarily. Consult the manufacturer's instructions to ensure that the AFCI is compatible with the equipment being used in the circuit. Sixthly, consider nuisance tripping. AFCIs can sometimes trip unnecessarily due to noise and interference in the electrical system. This is known as nuisance tripping. Nuisance tripping can be annoying and inconvenient, but it is important to remember that it is better for an AFCI to trip unnecessarily and to fail to detect a real arc fault. If you experience frequent nuisance tripping, consult a qualified electrician to troubleshoot the problem. The electrician may be able to identify and eliminate the source of the noise and interference. Seventhly, stay updated with code changes. The NEC is updated every 3 years. It is important to stay updated with the latest code changes to ensure that your electrical installations are safe and compliant. Subscribe to industry publications, attend training courses, and consult with qualified electricians to stay informed. Eighthly, use listed and labeled equipment. Only use electrical equipment that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories. All listed and labeled equipment has been tested and certified to meet safety standards. Using unlisted and unlabeled equipment can be dangerous and may violate local electrical codes. Ninthly, follow manufacturer's instructions. Always follow the manufacturer's instructions when installing and using electrical equipment. The manufacturer's instructions provide important information about safety, installation, and operation. Failure to follow the manufacturer's instructions can void the warranty and create a safety hazard. Tenthly, consult a qualified electrician. If you are not comfortable working with electricity, consult a qualified electrician. Electrical work can be dangerous and should only be performed by trained professionals. A qualified electrician can ensure that your electrical installations are safe and compliant with local electrical codes. Now let's delve deeper into the specifics of arc fault detection technology. There are primarily two types of AFCIs: branch/feeder AFCIs and combination AFCIs. Branch/feeder AFCIs, as the name suggests, are designed to protect the branch circuit wiring from arc faults. They typically detect high current arc faults, such as those that occur when a damaged wire comes into contact with a grounded metal surface. Combination AFCIs offer a higher level of protection by detecting both high current and low current arc faults. They are able to detect low current arc faults that may not be detected by branch/feeder AFCIs. Combination AFCIs are now the most common type of AFCI used in residential applications. The 2005 NEC and subsequent editions have expanded the requirements for AFCI protection in dwelling units. This expansion reflects the growing recognition of the importance of arc fault protection in preventing electrical fires. When installing AFCI circuit breakers, it's important to handle them with care to avoid damaging the sensitive electronic components. Do not drop or subject them to excessive force. Also, ensure that the circuit breaker is properly seated in the panel board and that all connections are tight. Loose connections can cause arcing and overheating, which can damage the circuit breaker and create a fire hazard. Before working on any electrical circuit, always turn off the power at the main breaker or disconnect switch. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. This is a crucial safety precaution that can prevent electrical shock. When connecting wires to AFCI circuit breakers, use the correct size and type of wire connectors. Make sure that the connectors are properly tightened to ensure a secure connection. Loose connections can cause arcing and overheating. After installing an AFCI circuit breaker, test it to ensure that it is functioning properly. Press the test button on the circuit breaker. The circuit breaker should trip and interrupt the flow of electricity. If the circuit breaker does not trip, it may be defective and should be replaced. It's also important to properly label the AFCI circuit breaker in the panel board. This will help to identify the circuit breaker in the future and prevent accidental tripping. Use a permanent marker or label maker to create a clear and legible label. In addition to the NEC requirements, some local jurisdictions may have additional requirements for AFCI protection. Be sure to check with your local building department to determine the specific requirements in your area. Remember, electrical safety is paramount. If you have any questions or concerns about AFCI circuit installations, consult a qualified electrician. They can provide expert guidance and ensure that your electrical system is safe and compliant with all applicable codes and regulations. The information provided here is for general educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.